This is an application of differentiation, which is finding limits by using differentiation, or called L'Hopital's rule. For example, if I have x squared minus 1 over x plus 1, or over x minus 1, and I need to put x equal 1, can I put x equal 1 here? No, I can't put x equal 1 because it is in the denominator, it is out of the domain, okay? But I can put a number which is approaching 1. It is not exactly 1. I need to know when x approaches 1, what happens to this function. Okay? So I'm not substituting with exactly 1. No, I'm substituting with, for example, 1.00001. A number which is approaching the 1 but not the 1 itself. Okay? I need to know what is the result when I take this point. This is called a limit of x approaching 1 of this function. How could I find it? The first method to find this is to make a simplification. Any cancellation, I make a cancellation, the necessary cancellation to make this limit. For example, this one, which will be x approaching 1, I make factorization in the numerator, which will be x minus 1, x plus 1, over x minus 1. So that will be, this is cancelled by this one. So that will be limit x approaching 1, which will be x plus 1, which will be 2. Okay? So whenever x here is approaching 1, the function is approaching 2. Okay? How would I graph this, for example? I may have this function. Okay? I may have this function. This function is 1 and here is 2. Okay? If I tell you what is f of 1, f of 1 here is undefined. F of 1 here is undefined. But when I tell you what is f of limit x approaching 1 of this function, you will tell me it will be 2. Why? Because the limit is not the function of the point 1 itself. It is the function of the neighborhood of 1. The points which are neighboring the 1. These points. Okay? So what are these? This is 2, this is that point that I need, and this is also another point. So when these two are identical, both will be 2. Okay? So this is how to find the limit. There are some tricks in this case. For example, if I have limit x approaching 1 root x minus 1 and x minus 1. In this case, I don't have factorization. But whenever I have a root, I multiply by the conjugate of that root, root x plus 1 and over root x plus 1. I didn't change the problem, I just multiplied by the conjugate in the numerator and denominator. Now, the problem will be like this. X minus 1 root x plus 1. Now I multiply a function and by its conjugate. Do you know what is the result of multiplying this by its conjugate? A number by its conjugate. What is the result? An expression by its conjugate. It will be squaring the first minus squaring the second. Difference of squares. So when I multiply an expression by its conjugate, it will be the difference of squares. Squaring the first minus squaring the second. Okay? So that will be squaring the first, which is x, minus squaring the second, which will be 1. Now after I have multiplied by the conjugate, now it is obvious that there is this cancellation, so that will be limit x equal 1, it will be 1 root 1 plus 1, which will be half. These are some tricks which we will not need it in our study, but it is just just as a revision. L'Hopital's rule tells me that whenever you have an expression, when you make a direct substitution in that expression, and you get one of these forms, 0 over 0, or infinity over infinity, or in 0 times infinity, or infinity minus infinity, or 1 power infinity, or 0 power 0, or 0 or infinity power 0. Whenever I have any of these 7 expressions are called indeterminate quantities. They are unspecified quantities. I need to specify them. At first they are not specified, but I need to specify them. How would I specify them? I may use the L'Hopital's rule. What is the L'Hopital's rule? For example, let's check that last problem. X squared minus 1 over limit x squared minus 1 over x minus 1. First, I try direct substitution. So I try direct substitution. It will be 1 squared minus 1, which will be 0 over 0. So this is one of the 7. Now I am allowed to use the L'Hopital's rule. If it gave me some number which is not one of these 7, I cannot use L'Hopital's rule. Okay? Now what is L'Hopital's rule? Now I am allowed to use L'Hopital's rule. What is L'Hopital's rule? L'Hopital's rules only operate on these 2. But if I have any of these expressions, I will convert them to these 2. We'll learn them now in the examples. How would I apply it? It just says that whenever I have indeterminate quantity like this, 0 by 0 or infinity by infinity, I differentiate, make a derivative of the numerator by itself and the derivative of the denominator by itself. So that will be 2x, which is the derivative of the numerator, divided by the derivative of the denominator, which will be 1. Now I make a direct substitution, which will be 2, which is exactly this result. So I made this, or I have found this result without the need to make any factorization, multiply by conjugate, any of these, no. Just by the derivative, I have managed to find the result of the problem. Okay? So let's apply this rule for some cases. For example, this problem, limit x to 1, ln x over x minus 1. First, we try the direct substitution. Direct substitution, it will be ln 1 over 1 minus 1. This is 0. What is ln 1? Do you remember? The graph of ln, you must memorize the graph of ln. That will be like this. You must memorize the graph of ln. Graph of ln, do you remember ln of 1 will be 0. Ln of 0, do you remember what is ln 0? 1. No. Negative infinity. When you approach 0, the function goes to negative infinity. So what is ln infinity? Positive infinity. Yes, in this case it will be positive infinity. When you make the x go to infinity, the function will go to positive infinity. Okay, so that will be 0. So this is 0 over 0. Can I apply L'Hopital's rule here or not? Yes, it is eligible for L'Hopital's rule. So I just make the derivative for the numerator and denominator, up and down. The derivative of ln x will be 1 over x. The derivative of x minus 1 will be 1. I just substitute, that the result will be 1. Okay? Let's check another example. If I have limit x approaching 0 e power x minus 1 over x squared. Substitute by x equals 0. That will be e power 0 minus 1 over 0 squared. That will be 0 and that will be 1 minus 1. E power 0 is equal to 1. Anything power 0 is equal to 1. 1 minus 1, that will be 0 over 0. So I can use L'Hopital's rule. Let's apply L'Hopital's rule. So that will be limit x approaching 0. The derivative of the numerator will be e power x as it is, minus 0 over 2x. Now let's apply or substitute x by 0. E power 0 over 2 times 0. E power 0 is 1. 2 times 0 is 0. What is this number? 1 over 0? It is infinity, yes. So whenever I have a case which the result is infinity or negative infinity, we say that the limit does not exist. Whenever I have the result as infinity or negative infinity, the limit does not, I say that the limit does not exist. Okay, or I say it approaches infinity. Okay, let's check another example. If I have limit e power x over x squared, x approaching infinity. In this case, x is approaching infinity. Let's check this problem first. Limit x approaching 0, tan x minus x over x cubed. Direct substitution, tan 0 is 0 minus 0 over 0. This is 0 over 0. I can apply L'Hopital's rule. Let's apply it. Tan x is x squared minus 1 over 3x squared. Derivative of the numerator, derivative of the denominator. Now I substitute x equal to 0. Sec 0, what is sec 0? Sec 0 is 1 over cosine 0. And cosine 0 is equal to 1. Remember, cosine 0, it is this point, the angle 0. The angle is 0. So this is, we are talking about this point. This point is 1 and 0. This is the cosine and this is the sine. You must remember the cosine and sine of the 4 basic angles. 0 and pi over 2, pi and 3 pi over 4 over 2 and 2 pi and so on. Okay, so this is 1 minus 1 over 0. So that will be again 0 over 0. Now it is again 0 over 0. What do you expect I would do?
Limit does not exist.
Yes. Take again, apply again L'Hopital's rule. Apply L'Hopital's rule again. So that will be limit x approaching 0. That will be, there is a simplification here before I differentiate again. What is sec squared minus 1? There is a rule for this.
Tan squared?
Yes, it is exactly tan squared. This is exactly tan squared. This is exactly tan squared. Now, if I make a derivative, what is the derivative of tan squared? It is 2 tan x sec squared x. 2 tan x power 1 times the derivative of tan, which is 6 squared, over the derivative of 3x squared, which is 6x. Now, if I apply x approaching 0, so that will be 0, tan 0 is 0 and 0. It will be again 0 over 0. But this, when you apply 0 for this one, this will be 1. Sec 0 will be 1. This will be 0 and this will be 0. There is a rule for this one. Whenever you are having functions multiplied and divided by each other, any part of these which gives me a number which is different from 0 or infinity, take it out. This is not equal to 0 or not equal to infinity. My problem remains whenever I have 0 or infinity in the problem. But whenever I'm multiplying by 2, by 3, by 4, any of these numbers, I just take it out like this. So this problem is exactly 1 times limit 2, 10. I take also 2 and 6 out, so that will be 2 times 1 times over 6 of 10x over x. That is my problem now. 10x over x. Any part of the problem, any of the factors that are multiplied and divided each other, that gives me, when I make a direct substitution, gives me a number different from 0 or infinity, I take it out. And I complete the problem without them. Why? To simplify my problem. If I make the derivative of this case, it will be a lengthy derivative. But if you take it out, it will just be a simple like that. It will be simple like that. So that will be 1 over 3, which is 2 over 6. The limit, if I now apply 0, this is also 0 by 0, so that will be sec squared x over 1. X approaching 0, so that will be sec squared 0 is equal to 1 over 3. Sec squared 0 is equal to 1, so that will be 1/3. This is the result of the problem. Okay, so I may use L'Hopital's rule again and again whenever I have an indeterminate quantity or unspecified quantity. Okay, let's check that other problem. If I have limit x approaching infinity e power x over x squared. Now let's make a direct substitution. E power infinity over infinity squared. What is infinity squared? It is infinity. E power infinity, a number which is greater than 1. A great number like e. Any number greater than 1 is a big number. If you multiply it by itself again infinite times, that will be infinity. Now this case, yes, I'm eligible to use the L'Hopital's rule. I can use the L'Hopital's rule here, because whenever it is 0 over 0 or infinity over infinity, it must be a numerator denominator, a fraction. The other cases we'll know how to deal with it. But in this case, I will just say that this is limit x approaching infinity. I will make differentiate the numerator, which will be e per x. Differentiate the denominator, which will be 2x. Now I make a direct substitution again. That will be e power infinity over 2 times infinity. That will be infinity over infinity again. I make L'Hopital's again. So that will be limit x over infinity. That will be e power x over 2. Now this will be e power infinity over 2. What is e power infinity? It is infinity. Infinity over 2 is infinity. So I say here that limit does not exist. Okay? Let's check this one. If I have limit x approaching 0 plus, what is 0 plus? 0 plus, it is because I can approach 0 from two sides, from this side or this side. This side is called 0 plus, and from this side is called 0 minus. Okay, so 0 plus is just 0.00 positive 0.001. What is 0 minus? It is just minus 0.00001. So 0 minus is just minus 0 plus. So 0 plus, limit 0 plus is cotan x over ln x. Why it is 0 plus? Because x must be positive inside ln. Do you remember that the domain of ln, anything inside ln must be positive. Anything inside ln must be positive. Cotan, now I have cotan 0 over ln 0. Do you remember what is ln 0? Minus infinity. What is cotan 0? Cotan 0 is cosine 0 over sine 0. Cosine 0 1 and sine 0 is 0. So this is infinity. Can I apply L'Hopital's rule? Yes. Because it is infinity, it doesn't matter the negative sign. I can apply the L'Hopital's rule, so that will be limit x approaching 0 plus. Derivative of cotan is negative cosec squared x. Derivative of ln is 1 over x. If I apply 0 here, I will get infinity, and cosec squared, I will also get another infinity. So I will just rearrange this expression. That will be limit x approaching 0. That will be, I will take this up to be x, and here is the minus. What is the reciprocal of cosec squared? I need to find it as a fraction, numerator and denominator. So this is exactly sine squared x. Do you understand? Do you grasp what I'm saying? At first, take this x to be above, it will be x cosec squared x. But I need the expression to be a fraction, something over time to apply if I need to apply L'Hopital's rule again. So I will just take this cosec squared to be 1 over sine squared. Okay, so this is the new expression. Now I put x equals 0, it will be 0 over 0 again. So I apply L'Hopital's rule another time. So this is limit x approaching 0 minus 1 over 2 sine x cosine x. Now I put x equals 0, that will be 1 over 0 because sine 0 is equal to 0. So that will be infinity or minus infinity, and the result will be this is limit does not exist. Okay? So these are cases whenever I have 0 over 0 or infinity over infinity. What if I have infinity minus infinity? For example, limit x approaching 1, x over x minus 1 minus 1 over ln x. If I make a direct substitution in this case, that will be 1 over 1 minus 1 minus 1 over ln 1. This is 1 over 0 minus 1 over ln 1 is 1, 0. So this will be infinity minus infinity. Infinity minus infinity is one of the 7 indeterminate quantities. This one. Infinity minus infinity is one of these. So how would I deal with it? Remember, now, it is indeterminate quantity. This is indeterminate. So I may apply L'Hopital. I may apply L'Hopital's rule. But the form is just not ready. I need the form to be numerator and denominator as a whole, not one term and another term. I need it as a whole to be numerator divided by denominator. Okay? How would I make that? Do you remember the cross rule, AB over CD? Do you remember what is the rule in this minus? For example, this will be BD and above would be AD minus BC. Do you remember this rule? مقص طريقة المقص أو اللي هي الكروس. فهنا or make a common denominator اسمها common denominator نفس الحكاية. So this limit x approaching 1, that will be x minus 1 times ln x, x ln x minus x minus 1. Now I apply L'Hopital's rule. This is a product rule. The derivative of first ln x plus x times 1 over x, product rule, minus 1 over, this is a product rule also, so that will be x minus 1 times ln x plus the x minus 1 times 1 over x. X over x, that will be 1. 1 minus 1 is 0. So that will be ln x over, this will be 1 minus 1 over x. So that will be ln x plus 1 minus 1 over x. Let's put x equal to 1 and let's check the result. Ln 1 over ln 1 plus 1 minus 1 over 1. That will be 0 over 0 plus 1 minus 1. It will be again 0 over 0. It will be again 0 over 0. So what I do in this case, I make another L'Hopital. So I make a L'Hopital for this one, that will be 1 over x over 1 over x plus 0 minus 1 over x squared. Now I apply x approaching 1. So that will be 1 over 1 minus 1 it will be 1 over 0, and this case will also be no, this 1, yes, 1 minus 1, yes, it will be 1 over, which will be infinity, which is limit does not exist. Limit does not exist. Another last case for this limit x approaching 0 plus of x times ln x. And again we have 0 plus because inside the ln must be positive. If I make a direct substitution, that will be 0 times ln 0. What is ln 0? It is negative infinity. We have learned that already. So it is 0 times infinity. 0 times infinity is one of the 7 indeterminate quantities. Is one of the 7 indeterminate quantities, which is this one. How? Now this means that this limit can be found by L'Hopital. Whenever the result is an undetermined quantity, it can be found by L'Hopital. But the form is just not ready. I need the form to be as a whole as to be as numerator and denominator. But this is a multiplication. I may take one of them to make it as a denominator. I may write it as ln x over 1 over x, or I may write it as x over 1 over ln x. These are two expressions which are the same as, or which are equivalent to the same original expression. Which is more suitable for L'Hopital? Just remember. Ln is a very heavy function. It doesn't move. It doesn't like to move. Algebraic and exponentials. Exponentials is the most light function. It moves around easily. The ln is heavy. It doesn't move around easily. So whenever I have algebraic, the algebraic, just like x, is in between. Okay? So whenever I have an algebraic and ln, and I need to move one of them to be in the denominator, which one do you expect to be moved? I have an algebraic function and a ln function. Which one do you expect that will move?
X.
The x or the ln? I just told you that the ln is very heavy. It's very heavy.
So the x.
Yes, I move the x. So this one is more suitable. This expression is more suitable for me. So this limit, it is limit. It will be like this. Limit x approaching 0 plus. Now, I will just now apply L'Hopital's rule. Ln x, the derivative of ln x is 1 over x. The derivative of 1 over x is minus 1 over x squared. I make simplification, this will go this, so that will be minus x. I make a direct substitution, it will be 0. So the limit of this one is just 0. Okay? Okay, enough for today.